Oh, come back. So they're all very colorful. So in this chemical equilibrium, you see that the product side is yellow and the reactant side is orange. Product side is yellow, reactant side is orange, and that's why they do it. That's why they do what they do. I'm going to kind of go back and forth. That's the chemical reaction on page 291. It says you're going to take 3 mils of 0.1 molar, that's chromate. Dichromate's the other one. So chromate is, and that, your stuff is kind of from left to right here. Okay. And so what I've done is, it says you need 3 mils of this yellow stuff. So for each of your solutions, I went ahead and put a beaker back there. Okay. And then we have two pipettes, 2 disposable pipettes. This is the non-graduated one. If you squeeze the bulb really good and suck it up, you get 3 mils. I checked it today. And your write-up says you don't really have to be exact about the volumes. So 3 mils of this, and then you guys have a test tube rack. Okay, so grab a test tube, put 3 mils of that in there. Then your instructions say to go ahead and add 3 molar H2SO4 dropwise until you see a color change. Okay, so you're going to take this, which is yellow, by the way, that's consistent, or sorry, this, which is, well, it looks yellow to me, okay, and you're going to add, this is the 3 molar H2SO4 dropwise, and I'm kind of going back and forth. I should just move this down here. So let's see, I have some hints here. So when you add your H2SO4, that's actually a source of your H+, and it's like adding a reactant, so it should favor the product side. Again, to me, that looks like it's yellow under there, but it really should be orange. So I don't know if I got those mixed up. I don't think I did. So then I'm going back to the paragraph. It says record your observations in your lab notebooks. And then you're going to go ahead and add sodium hydroxide. Now, when you add sodium hydroxide, what you're going to do basically is use up some of your H+. So it's like removing H+. So if you pull the H+, you would expect what? It would favor, again, the reactant side. So that's the sort of thing we've talked about in class, changing the concentration and expecting a change in the equilibrium. So write down your observations and then discuss them in your write-up. The next one looks like this. So kind of this first hood has reagents for the first 2 things. So it says that you're going to have 3 mils of the cobalt-2 chloride in 3 test tubes. So in this case, you need to pull up 3 test tubes, do like 3 big squirts of this, or excuse me, 1 big squirt of this in each of your test tube. That should give you 3 mils. Okay. Then it says that, and it is pink, like it says up there. Then to 1 test tube, you're going to add 2 mils of concentrated HCl. Now, I haven't divvied up the HCl yet, but I'm going to. I have the big old jug of concentrated HCl here. I have a little thing right here in front of the HCl. Now, for this one, I use the graduated pipette because this, like I said on the board, if you squeeze it and you go up to, I think, maybe up here, 1 squeeze, that's 1 mil. So when it says 2 mils of concentrated HCl, you need 2 of these. So what you're doing there is actually a source of the chloride ion. So let's see if it goes ahead and favors, it's already pink. Let's see if it gets any pinker. So record your observations. To the second test tube, you're going to add ammonium chloride. Now, ammonium chloride, if you read in the background, is a little bit confounded because ammonium chloride, actually it's an endothermic dissolving process. So it's going to remove some of the heat. This thing is highly exothermic, so you're kind of removing heat. Okay, so you would expect it to actually favor the product side, I think. The other thing ammonium chloride does is like the HCl, you're adding chloride ion. So that solid, that 1.5 grams of NH4Cl actually is right here in one of these 2 boats. So that's your solid in your second test tube. And then I think your third test tube, okay, nothing in your third test tube. Oh, wait a minute. Yeah, nothing in your third test tube. Now, Now what you're ready to do is to take all three, and I have extra test tube holders under the screen there. You want to basically take all three of your test tubes and put them in here. Okay, so it's going to look like this. This is your hot water bath. Okay, and then it says record what you observe. So the point here is now you're adding heat. Okay, so if we're adding heat and it's highly exothermic, we would expect maybe it to go back that way. But write down your observations because you have three different test tubes. One has concentrated HCl, one has ammonium chloride, one has nothing in it. So see what your observations are. Do you get the blue? Okay, or is there something kind of interesting going on? So that's the second one. The third one looks like this. This is one of my favorites. Here's the chemical equilibrium for this one. You have tan and red, blood red sort of things going on. Your instructions say take 1 ml of the iron 3 nitrate. And in this case, you're not going to put it in a test tube. You're going to take your 1 ml from here, because I put a little skinny thing here. You're going to take 1 ml of this, and you're going to put it in a 100 ml beaker. Okay? And then it says, I believe, take 1 ml of this. So those are your two reactants. That's your Fe3+, and this is your source of SCN-. Okay, the thiocyanate. So you have 1 ml of each in a 100 ml beaker. Record your observation, I think. And then it says, go ahead and take that 100 mils and dilute it up with 50 mils of water, about 50 mils of water, because it's just too intense. Just too much, too intense. And then you're going to take 5 mils of that diluted amount and put it into 3 test tubes. And you're going to do something different with each of those 3 test tubes. So to the first test tube, you're going to add another mil of your first reactant, that iron 3 nitrate. To the second test tube, you're going to add 1 mil of the second reactant, the potassium thiocyanate. And to the third one, you're going to add 1 mil of something you've used before, which is in this middle hood, the sodium hydroxide, to the third test tube. So let's see what I got. Okay, so of course, in your first two, you're adding reactant. Okay, so you're adding reactant here, you're adding reactant here. When you go to add your sodium hydroxide, here's what's happening, and it's in your background information. The hydroxide actually removes the iron 3 by forming this complex. Okay, so in that third test tube, you're actually removing the iron 3. So let's see if it goes back that way. In your fourth one, and we'll be talking more about in this unit about these precipitation equilibria. Okay. Basically, we're looking at a solid silver chloride, which is pretty insoluble, dissolving it. Okay, so it's going from solid to aqueous. And so your instructions here say you're going to take 3 mils of 0.1 molar silver nitrate. It's in that last hood. So a big old big old pipette squeeze. And then you're going to add drop-wise NaCl. And notice that right away, what's going to happen is this exchange reaction that's in your background information. Right away, with that first drop-wise NaCl into your silver nitrate, if it can precipitate, it will. And it will. Silver chloride will precipitate. But it will be in equilibrium with the dissolved silver chloride. So then it says, once you have that, record your observations, and then to that same test tube, add 1 mil of ammonia, and that is actually in that third container over there. So 1 squirt of that from a small pipette, and record your observations. Now, when you add NH3, what happens there is, what happens with your NH3 is it reacts with your silver ion, okay, and it basically removes it. So if you remove your silver ion, what do you think is going to happen? You would think it would go this way. Okay, and what is this? This is solid dissolving. So we'll see if that's kind of what you see. And I think that's it. Okay, so I'll push these out there for you to mull over, but that's kind of what you guys are doing in a nutshell.
You ready?